You wake up, and something feels wrong before you even open your eyes. The ground beneath you, which has been silently carrying you at over 1,000 miles an hour your entire life without you ever noticing, has just stopped. And in the next 10 seconds, everything that wasn't bolted down on Earth is about to become a projectile. That's the real answer to today's question. What if the Earth suddenly stopped spinning? Not a slow, gentle deceleration. An instant stop, right now, this second. The good news. This is physically impossible to happen naturally that fast. The bad news. The physics of what would follow is far worse than most people imagine. This isn't just an idle thought experiment. Earth's rotation is the quiet engine behind almost everything we take for granted. Our day-night cycle, our climate bands, even the magnetic field protecting us from the sun. Scientists study rotation using satellites and atomic clocks precise enough to detect that our planet's spin is already changing, by fractions of a second per century, from things as small as melting glaciers redistributing weight, or the aftermath of major earthquakes shifting mass toward or away from the planet's axis. Even the 2011 earthquake off the coast of Japan measurably shortened our day, by a tiny fraction of a second, simply by moving enough mass closer to Earth's core. Stop that spin completely, and you're not tweaking a minor setting. You're switching off the operating system. Here's the one concept you need. Everything on Earth's surface, including you, the atmosphere, and the oceans, is moving with the planet at whatever speed the ground beneath it spins. At the equator, that speed is about 1,040 miles per hour, roughly the cruising speed of a passenger jet. Near the poles, that same rotational speed drops close to zero, which is exactly why a stopped Earth would devastate the tropics first and spare the poles almost completely. You don't feel any of this normally, the same way you don't feel a train moving smoothly at constant speed. But the moment the ground stops and the air doesn't, that shared motion turns into the single most destructive event in human history. Because air has mass, and mass in motion carries momentum. If the solid Earth stops but the atmosphere keeps obeying the same law of inertia that kept you moving all along, the air near the equator keeps traveling at that same 1,040 miles per hour, relative to the now stationary ground beneath it. That's not a strong wind. That's faster than most hurricanes, faster than most tornadoes, close to the speed of sound itself. So let's walk through what actually happens, stage by stage. First, in the initial seconds, anything not firmly anchored, cars, trees, loose soil, entire buildings not engineered for that kind of load, gets scoured off the surface near the equator by supersonic wind. This isn't a strong storm. It's closer to the shockwave of an explosion, sustained for hours, strong enough to flatten reinforced concrete and strip topsoil down to bare rock across entire countries near the equator. Then, within minutes, the oceans, carrying that same inertia, keep surging toward the poles, since Earth's rotation is also why the planet bulges slightly at the equator and flattens at the poles. Without spin holding water outward, gravity starts pulling that bulge back in, and the ocean begins a slow, colossal migration, drowning coastlines that have never seen a flood in recorded history. At the same time, the solid crust itself is under strain. That equatorial bulge isn't just water, it's rock too, roughly 13 miles taller at the equator than at the poles. Removing the spin that built that bulge would trigger enormous stress along fault lines worldwide, very likely setting off earthquakes on a scale far beyond anything in recorded history, as the crust slowly settles into a rounder shape. Within hours, the day-night cycle changes completely. A spinning Earth gives you a sunrise every 24 hours. A stopped Earth would instead take a full year to complete one day, because it would still orbit the sun, just without spinning on its own axis. One side of the planet would face 6 months of daylight and brutal heat. The other side would face 6 months of darkness and cold far beyond anything humans currently experience. Here's the twist most people never consider. The crust and oceans aren't the only things spinning. Deep inside Earth, a churning ocean of molten iron in the outer core generates our planet's magnetic field, through motion driven partly by rotation. Slow that motion down enough, and the field that currently shields us from the sun's charged particles would begin to weaken, over years and decades, not seconds. We actually have a preview of what that looks like. Mars once had a magnetic field of its own, generated the same way ours is. Billions of years ago, that field faded as the planet's interior cooled and its dynamos slowed. Once the shield went down, the solar wind spent eons stripping away most of Mars's atmosphere into space, leaving the thin, cold, mostly airless world we see through telescopes today. Venus offers the opposite lesson. It spins so slowly, once every 243 Earth days, that its own dynamo barely functions, and it has almost no protective magnetic field at all, despite being similar in size to Earth. Rotation, or the lack of it, appears to be part of the reason two planets so alike ended up so different. That's the edge of what we know. A sudden stop unravels Earth in minutes, through wind and water. But a slow stop unravels it over millions of years, the exact same way it already happened to our closest planetary neighbor. So here's the honest answer. The sudden version is a planetary-scale catastrophe measured in hours, with winds and floods erasing entire coastlines before most people even understood what had happened. The gradual version is a slow-motion transformation into something closer to Mars, measured in geologic time, unfolding so slowly that generations would live and die without noticing the shield above them weakening. Either way, everything we call ordinary weather, ordinary daylight, even the invisible shield over our heads, depends entirely on this planet never quite stopping. There's another everyday certainty this series is going to take away from you next. What happens if the sun that powers all of this simply disappeared? That story is coming up in this series, so subscribe if you don't want to miss it. I'll see you at the edge.